Okay everyone, hello and welcome back. So here's example 3.4, and as you might be able to guess by it giving us a distance, it's going to figure out a moment this time. We're not just doing our forces, we're also going to be taking into account a moment. So what it says is solve for the moment of each of the forces applied about point O. And these forces are applied at point A, okay? I want the moment around point O though. That's what I need the moment around. So I want to find the moment of each of the forces. Well, remember, it's always the perpendicular distance from the force to its line of, from the point about which the moment is being calculated to the force's line of action. So let's draw those lines of action. Okay, so that's that line of action, and so as you can see, that's really easy. That one's a right angle already. That one's vertical, this is horizontal. I'm good there. Okay, how about this one? Well, let's look at its line of action. And you might notice that for the force F1, its line of action goes through O. So what's the distance from O to that line of action? The perpendicular distance. It's 0. It means that this one doesn't have a moment. And then for this force 3, well, it's harder to get its perpendicular distance. If we know what this angle 30 degree is, and we know that this length 5, well, we can figure out that D is going to be opposite over hypotenuse, which is D over 5, and that's going to be equal to opposite over hypotenuse, which is sine of 30. So sine of 30, or that D will be equal to 2.5. Okay, now let's check and make sure I did it correctly. So first off, F1, line of action passes straight through that. We have this infinitely long line in either direction, and it hits point O, so no moment. Second force does cause a moment, but luckily it's perfectly perpendicular, so there's no trig involved. It's a perpendicular force to this perpendicular distance. And so it'll be 5 times 75. Now is it a positive or a negative moment? Well, let's draw our vector, go right here, and then I turn with it. Whoop. And what direction did I turn? Remember, you always start at the point, you draw towards the force, and then you follow the force. Well, I turned in a counterclockwise direction, and that's positive. So it's a positive moment. This last one is a little bit more difficult, but it's not too terrible. We're trying to find this perpendicular distance, and this just turns into a right triangle. So what I did last time was I said, okay, well, let's solve for D. D over 5 is equal to opposite over hypotenuse, which is sine of 30. So D is equal to 2.5. That's one way you can do it. And you get 150 foot-pounds. And is this a positive or a negative moment? Well, drag and find out. And, well, that would actually be a negative moment as it's clockwise. I don't put the sign there, but it would be a negative moment. The second way I could do it is just to say, okay, well, rather than worrying about all this nonsense right here, I already know what this distance is at this point, so let's just find a perpendicular force. Okay? And so this is 60 degrees right here. Okay, cool. I can do this. And let's see right here. Okay. So we'll call this F3y. Okay, so F3y over 60 is equal to adjacent over hypotenuse, which is cosine of 60. Okay, fantastic. And so F3y is equal to 30. But what do you know? 5 times 30 is still 150 foot-pounds. It'll be the same either way you do it. Either you find the perpendicular distance or you find the perpendicular force. Whichever one is easier. That's all you have to do. And so with that, we have finished this problem. So, thanks for watching, thanks for listening, and I'll see you all next time. Have a wonderful day. Bye-bye.